Hi, everyone. First of all, thank you for inviting me to join. I'm super excited to talk to this forum on attestation. So what I'm actually going to cover is not attestation itself. Okay, so I'm sure this forum, you are great attestation experts, and I'm not. But what I will talk about is actually how your important work is actually used by us and can be used by the larger industry. And there's actually super interesting things to talk about, and this is what I'm going to cover today. I'm going to start by presenting Upstream, so myself and Upstream. So again, my name is Yonatan Appel. I'm the CTO and co-founder of Upstream Security. We are a company that's completely focused on mobility and automotive cybersecurity and quality. We work today with many OEMs protecting over 30 million vehicles out there, 7 million API consumers, and monitoring billions of transactions a month. We work today with 17 OEMs and actually monitoring vehicles worldwide. Okay, now what we do essentially is process vehicle data at scale using AI. And actually, what I'm going to cover today is how actually attestation data can be super valuable for everything that we do. Okay, so to talk a little bit about what we do at Upstream. Okay, so essentially, like I said, we work with many OEMs out there. And we have a platform that is the Upstream platform, and this platform is a mobility platform that, based on AI and digital twins, basically processes vehicle data and produces various types of vehicle insights, both for individual vehicles and multiple vehicles in real time. And OEMs use us to monitor their high-valued use cases, especially cases where anomaly detection is needed. So how does it work, essentially? So our platform is usually installed in the OEM premise. We connect to all the relevant data sources related to connected vehicles. These are, first and foremost, the telematics information, IoT information, API data, software update data, diagnostic data. So all of the essential data sources that actually describe the vehicle's activity, we connect to it, we stream it into our system. Then we have two fundamental technological steps. The first one is that we create a digital twin. We create a digital twin which is individual for each and every asset. So for example, if the OEM has 10 million vehicles, for an example, connected vehicles, so we will have 10 million digital twins for each and every vehicle with its state and its information. We also have kind of collective digital twins that can describe the behavior of a vehicle model plus year, architecture, ECU, whatever is relevant to be described, but collectively. So this is another type of digital twin. And this is the state layer. Above that, we have the anomaly detection layer, which is essentially AI. So we build many types of machine learning models that detect anomalies both for individual vehicles and for collective digital twins. And above that, we have the application layer. So today we focus on two fundamental problems that problems that the OEMs are facing. The first is cybersecurity risk, attacks on individual vehicles, but also on fleets of vehicles. And of course, connected vehicles have significant risks. And the second application is proactive quality detection, which detects quality issues that are high risk, systematic risk for the OEM. How it works. So very shortly, we install our platform in the OEM premise, connect to all the relevant data sources, and apply monitoring and anomaly detection. Last thing we'll talk about, like on the technological level, okay, is our digital twin. So digital twins are centric to everything that we do. Essentially, it's an advanced domain-specific plus AI state of the asset. It has raw signals from all the relevant data sources, inferred data, events that show the asset's history and timeline, anomalies, and external data. Okay, so this is about us in a nutshell. And now let's go to talk about the specific problems that can be addressed through attestation. Okay, the first one we will talk about is cyber. Okay, so of course OEMs with the connected vehicle space have significant risk for cyber attacks, both in the vehicle and remotely. Just a short, taste from the last 2 or 3 months. Okay, so we see, of course, everything here is public information, so don't worry. But again, we can see that since September, okay, these are high-profile attacks that were published. We see different OEMs that have been attacked in various types of attacks. You see attacks that actually stop the OEM vehicle production. You see other attacks that were on third parties, ransomware, data theft. So you see all of these attacks, and again, this is just from the 3 months. So you see that basically attacks cause a high risk for the OEM, their data, their customer privacy, and of course, the ultimate risk, which is functional safety. So if you look at all these attacks, these are high-profile attacks that actually affected these OEMs. None of these attacks actually reached vehicles in production. Okay, they could, but they didn't. This specific set of attacks. But I would like to talk about another attack. Again, everything here is public. Okay. And this is an attack that has been recently, a research that has been recently performed by Kaspersky. And what they showed is how they can actually quite easily start in an attack vector that is public, an attack surface that is public, almost naive, okay? And from there, elevate themselves and reach the vehicles, okay? So this was a research that was done on a connected vehicle provider. What they did, okay, so if you look at the example attack flow, attack chain, so they first actually did a simple SQL injection attack on a wiki application that was exposed to the internet. Based on that, they were able to find information that exposes credential to a ticketing system. They went to the ticketing system, again, just a regular IT, very simple application. In the ticketing application, they actually found credential that enabled them to reach the telematics server. And then they reached the telematics server, leveraged a misconfigured gateway. And by doing this type of elevation, they were actually able to send a malicious OTA to the vehicle. Once they did that, they were able to control the vehicle function, safety, just through CAN commands, they were able to control the vehicle. Okay, so again, good news, this is only a research, okay, but this thing can definitely happen. And if we look at this specific attack, when you're able to send your own software to the vehicle, that's like game over. Okay, you can fully control the vehicle function and cause a safety risk to the vehicle owner. Okay, so and we look at this type of attack. Okay, think of even an attack at a larger scale. This is something that attestation can help us detect. Okay, so if we take this and see how monitoring can actually help detect this kind of attack and other types of attack. Okay, so first of all, when we look at the digital twin of the vehicle, so we look at the vehicle as, the vehicle is one complete asset, but it's actually made of multiple ECUs, and it's actually a hierarchical structure, and per each and every ECU, we keep the ECU information, including software version, cryptographic materials, and any information that actually will be supplied by the OEM. So when we look, for example, at such a scenario, okay, so if the attacker actually was able to take over the OTA, they not necessarily can push any software that they want to the vehicle, okay, especially when there's attestation, okay, so the most they will be able to do is actually throw software that is older in order to detect vulnerabilities, and this is something that is detectable through monitoring of the vehicle state. Okay, so essentially, what we can see here is that we can take the attestation result, which basically attests to the software that runs in the vehicle, and detect uncommon, anomalous software, do fleet comparison, detect rollbacks, which are unexpected and actually an anomaly, as you can see here. Okay, so attestation basically enables us to detect vehicle-related anomalies in real time, including the downgrade and including the usage of unexpected software version. Additionally, when the attestation is performed on the vehicle, okay, so the vehicle can send us attestation errors, attestation assessment, attestation information. This can be done either through various types of errors, message, telematics information. What we see in practice out there is that it's also sometimes done through DTCs. And basically, all of this information can be used in order to detect vehicle anomalies, vehicle tampering, unexpected behavior, risk, use this risk to do investigations, find out rogue location, bad dealer, and generally tampering of the vehicle. Another kind of interesting angle is the ability to look at attestation anomalies in their larger context. Okay, so we can say, okay, there's an attestation anomaly, but why did it happen? Okay, so for example, we can see that there are attestation issues in the same location. So maybe it's actually a shop that's actually violating the OEM's terms and condition. Okay, so basically correlating all the data sources with the digital twin enables us to contextualize the attestation issue, reach the root cause, and actually perform either engineering remediation or operational remediation. Another angle that I want to touch on, very kind of small, but I think is very interesting, is the ability to do remote attestation. So remote attestation can be done using the digital twin, and it actually has an advantage because it's actually dynamic. Okay, so when you do the attestation remotely, you can basically both use dynamic signing material and update, if something was compromised, but also again do baselining, do anomaly detection, even in valid situation to detect unexpected software versions. And when you do it remotely, you can also trigger workflows both in the vehicle, in the backend, perform monitoring and investigation to handle the issue. Okay, so all of these functionality can be reached using a remote digital twin. Another quite interesting aspect I want to touch is actually attestation as part of the remote larger PKI flow. Okay, so OEMs today use PKI flows in order to actually manage authorization of the vehicles. This is actually quite interesting because the modern connected vehicle actually consume many types of services from the OEM. Some are privileged, some are paid, and all of this is done through authorization through PKI. What we see, okay, I'm sure you guys are expert in this, but we see that attestation is actually part of this process, and attestation is done as part of the larger authorization process. And again, here, it can be subject to attack. Okay, what we see in the market, so we see various operation, chip tuning, counterfeit parts, rogue shops doing various operations on the devices for various targets, that essentially what we see in the field, okay, in our VSOC, like in our SOC services, is that we see many times that there are parts manipulations. Okay, and this is like just as one concrete example. Okay, so you see same part using concurrently on multiple assets. Okay, I think it's a little bit similar to the previous speaker's note about geographic wisdom as a side, information on attestation. And essentially what you can do with a digital twin is monitor the attestation as part of a larger privileges grant process that is fundamental to the vehicle's normal behavior as a connected vehicle that consumes services. And again, we can both monitor using the digital twin attestation anomalies, but also attestation anomalies in the larger, in the context of the larger authorization grant process, which is again fundamental to the whole behavior of the asset as a digital twin. So that was in the cybersecurity area. I want to also briefly touch attestation in the quality and right to repair context. So just to give like some context, okay? So vehicles, as we all know, are becoming increasingly connected, increasingly updatable, and software-based, okay? So this means that if we look globally, a growing, okay, and larger part of after-sales issue, warranty claims, quality risks are becoming related to software, okay? When we look at this larger industry context, we see that attestation can be actually pivotal to help actually detect quality issues and reduce risk. Okay, so if we look at the quality problem, we divide it into two types of problem. The first one is what we call claim analysis. Okay, so all OEMs today have big departments that are called after sales that process claims, warranty claims from the field. This process today is reactive, and basically what the work we're doing with OEMs is again leveraging the digital twin to basically connect between connected vehicle telematics information and claims. And this can actually help detect and anticipate kind of strategic software issues in advance. The other thing that the industry is looking for, and we're helping, is for early pre-claim detection of quality issues. So you want to basically detect an issue before it becomes a claim. Just as an example, a software update has some bug in it, and it basically causes a large malfunction. And this is what we call pre-claim early detection. So these are, again, big challenges for all OEMs today. All OEMs are looking at this today. And all of this actually is the idea to take connected vehicle data, take software-related data, and connect it to quality issues. And this is exactly where attestation can be pivotal, okay? So with SDV becoming so strategic for all OEMs, attestation can actually help us understand, first of all, that the software has integrity, okay? If there's integrity problem, this can be, of course, connected to warranty and quality issues. But also, more like interestingly, okay, so what we see many times is that software version are actually a source of bugs, which are quality issues. It can be a battery that's a high voltage battery that's going wrong. It can be a 12-volt battery that has kind of ignition off draw. It can be an infotainment issue. And basically, when we take attestation information, okay, of all the various components, and the richer it is, the better, then we can use this information for machine learning that can help us correlate between the software that runs in the vehicle and quality issues. This is super strategic and powerful to help after sales issues and engineers go to the root cause of issues. Another issue, I would say a little bit less strategic, but still very interesting, is right to repair. Okay, so right to repair, it's essentially a balance between the OEM's desire to keep control over the vehicle, but we want to democratize the ownership of the vehicle owner of his vehicle and his ability to control the vehicle. And essentially, when we use attestation, this can help us detect legitimate right to repair actions versus illegitimate that can actually void the warranty. Okay, so all of this is basically enabled by attestation. And this is why we see attestation information as super valuable and helpful to, to us, but basically to helping OEM address their strategic challenges. Okay, so this was that is basically what I wanted to cover, and I'll be happy to take questions, comments.
Okay, so thank you, Yonatan. So I'll start with a question, and then I see Osama will follow. So my question is, today you work with a lot of vendors in the automotive area. What is the quality, or if you like, the trustworthiness of the information that you receive from vehicles today, and how far is it from where you'd like it to be? Don't name anyone specific, but just in the general sense.
Yeah, so I think we made a lot of, we started around 7-8 years ago. And I think the good news, okay, is that the industry is progressing very fast. We see all OEMs putting more trust into the ECUs and actually sending, which is even more important, sending stronger and stronger telemetries to the backend, which helps us, give more and more value based on the data. There is, as specifically for attestation, so there is some data. So there is some attestation data today. There is PKI data, okay, and there is functional data, sensorial data. Some of it is through telemetries, and some of it is through DTCs, okay, so, and some of it is through logs, okay. So I think there is data. I think the industry is progressing fast. Are we where we want to be? So I think I would say in the next few years, I think additional progress will be made.
Okay, thank you. So Osama.
Yeah, thanks very much. It was very interesting to see how the attestation that we work on can be applied in the real world. So from that perspective, I had a few questions. I will start with the first one. Could you kind of explain me how this relates to what Ned was presenting, like the kind of architecture which Ned and Hank showed? As far as I understand, you have the vehicles which are the attester, right? Is it correct so far? So you are attesting to these vehicles. The software or the firmware or whatever is in the parts are in the vehicle. Is this correct?
So just to talk about the name, so this is the RATS presentation. That was the
Yes, yeah. So we like who is the if you're not familiar with these terminologies, so is it the vehicle that you are checking? I'm using the word checking for a tester in that sense.
So I'm actually, of course, not an expert, but I am familiar with the terms. Okay, so
okay. So then, who is the tester in this case? Is it the vehicle?
So yeah, I was actually alluding to this when I spoke, but maybe not clearly enough. Okay, so there are, I would say, 3 scenarios. Okay, scenario 1. Okay, I will try to be more clear. Okay, scenario 1. The vehicle itself is the attester, okay? And when there are attestation issues, the vehicle sends telemetry that reports about it. Scenario number 2 is the OEM is the attester, okay? And scenario, I would say number 2.5, okay, is that we could be the attester, okay? So first of all, today, okay, just to be super clear, so today we do not ourselves do attestation. I think we could, okay, but we don't do it today. Okay, we do other stuff related to attestation and PKI, but it's essentially more of monitoring the attestation and monitoring attestation versus the vehicle behavior. Okay, so this is what we do, and we think this is super valuable because today at the OEM, it's really hard to connect the dots. What we do see out there, okay, we do see remote attestation out there. I was actually talking about it in the PKI slide. we see it as parts of overall flows to actually grant vehicles privileges. Okay, so 2.5 scenarios: local, remote, and remote that we would do. Okay, but what we, again, this could be futuristic. It's super interesting. What we do today is basically do anomaly detection on the attestation connected to other parts of the vehicle.
So right, maybe a very quick question, which you maybe probably give a short answer. So the very first scenario that you have where vehicle is the attester. Number one, there are privacy issues. Like if I would be very
ready.
So I would be worried about someone, let's say, getting the data of my vehicle. It can be used for tracking wherever I'm moving, wherever my vehicle is going. So all the time I'm being tracked. Number two, even if I apply remote attestation in this scenario, how would the OEM actually get these values in order to check whether whatever you are attesting to, which I still do not understand, but whatever you are attesting to, how does the OEM, in this case, probably is the relying party, so how is that getting these values to compare against that, whether it's correct or not? Can you say it shortly about that?
So the short answer, okay, is and again, this is something we would see. Okay, so let's say that there's a secure boot. Okay, so this is an error that can be tracked and monitored. Okay, like secure boot, attestation. So all of this is actually a tampering evidence, and this is something that can and actually should be monitored by the OEM. Okay, it's not a privacy issue. Okay, just okay, so it's not that private key material is exposed. Okay, what again can and should get exposed. Okay, this is actually required by regulation. Is if someone is tampering with the vehicle, okay, and therefore compromising the vehicle software, this might be a cyber attack on the vehicle, cause risk to the vehicle owner, and therefore it should be monitored. It's actually obliged by regulation. So again, every data that leaves the vehicle, of course, has a privacy implication, but the regulation already did this balance. And the R155 regulation tells all OEMs that they actually must detect cyber attacks on the vehicle. And this is, of course, an indication of tampering through attestation is an important cyber evidence.
Okay, maybe I will follow up later on.
Yeah, I was going to say we have short time. I'll let Yogesh, Ali, and Bill speak, but after that, I think we'll have to wrap this up. So, Bill, were you responding directly to the last topic?
Yeah, I do have some responses directly to the last topic. I mean, it is most important to understand that the priority of security on the vehicle is security of the physical actuation of the vehicle at the time of that actuation. And so that's why the priority is put towards secure boot, which is a form of attestation, but a more localized form. And perhaps there are some principles of what we learned today that we can apply to characterizing the secure boot necessary. But understand that there's not enough time to go and send things back to a remote call center and figure out somehow across the millions of vehicles across the globe what is going on in some kind of compromise. The priority is instead to secure the physical output so that we avoid some kind of malfunction, safety, theft, etc., of the vehicle itself. And so that is part of the perspective of attestation that I wanted to add to this conversation, and maybe hopefully tie that into some of the conversations we're having in the Automotive Task Force related to secure boot of automotive systems.
Okay, thanks, Bill. So I'll hand the microphone to Yogesh.
Hi, thanks for your excellent presentation. What I wanted to check with you is, without naming any particular vendor or something, you mentioned quite a bit about attestation in automotive industry? Are they looking at the standards, or are the vendors having their customized proprietary implementations? Would like to know that.
So how attestation is implemented by OEMs, I'm not personally familiar with. So if someone else knows the answer, not me. Again, like just on what we do, so we do not implement attestation, we just consume the results.
Okay, thanks. And Ali?
Hi, Yonatan. Thanks for presenting that. I suppose this question goes back to the discussion around the vehicle attestation, and again, it's more a question to the group. It will be useful to understand. So a lot of the attestation that we look at, that's coming from the IETF and from the trusted group, is about the secure boot and componentry at that level. How that maps to an ECU in a vehicle. How you get from that level to the vehicle doing attestation isn't entirely clear, because the vehicle isn't a singular thing. It's actually a combination of lots of ECUs and sensors and other things networked together. So it's not entirely clear how one gets to attesting an ECU to attesting a vehicle. I don't know if that question makes sense, but that isn't entirely clear
Yeah,
at the moment.
I will. So I will answer. Thank you. The question is clear. So the way it works. So when you do the attestation, again, if it's not a distributed flow, okay. So you're within a component. So you're within an ECU, and then the result of the attestation is sent, okay, to another node in the gateway, which is the endpoint for the remote communication. So the vehicle has kind of, you can look at the vehicle as it has two sides to it. Okay, one, it's the vehicle that has ECUs, it has CAN and Ethernet networks. The second side of the coin, okay, that it's connected through an IoT, like through a SIM card to the backend. This is like the SIM card is the physical, but it's above usually MQTT or some other protocol. Can be encrypted with TLS. Okay, so the answer to your question, you can look at it like an onion tunneling. Okay, so there will be a component in the vehicle that will maybe the gateway or the TCU or another one that will get the attestation result, wrap it in a telematic message, and will send this payload over MQTT or any other IoT protocol encrypted to the backend. Okay, so this is how it would work. And therefore, it's like peeling the onion. Okay, so the relation to the vehicle, it's just like taking the outer layer, peeling it, and then you can see the ECU level information. This is how it's done.
Okay, thank you,